Here are some simple examples of multiplying with radicals. So in the first example, we have a multiplier on the outside, the square root of 5, and we have two terms inside, so we will distribute the outside multiplier to each of the two terms. So the first term that I get is square root of 5 times square root of 20. And then the second term, so I've got a minus in the middle, we'll take that square root of 5 and multiply it by the square root of 10. And for each of the terms that are multiplied, we should put the radical factors under the same roof. So I will take 5 times 20, and this becomes square root of 100, minus, and then multiplying square root of 5 times square root of 10. Again, we put the two factors together and make square root of 50. So the first term is very simple. This just becomes 10 with no radical. And for the second term, we can simplify it by separating it into its perfect square portion. So the square root of 50 has factors of 25, which is a perfect square, times 2, square root 2. And we divide it up this way, square root 25 and square root 2, rather than root 5 and root 10, say, because we're targeting those perfect squares, such as 4, 9, 16, 25, and so on. So now we can finish this off and then just take the perfect square and change this root 25 into a 5. So this now becomes an outside number. It is outside of the radical, and the radical portion is much simpler. We have just the square root of 2. These two terms are unlike. 10 is a rational number, and negative 5 square root 2 is irrational. This root 2 is unlike the integer portion here, so again the term stays separate. For the next example, inside these parentheses we've got a binomial. We have two terms, and the second set of parentheses also has a binomial. So in this example we will use FOIL. Taking the product of the two first terms, we've got square root of 2 times 2 square root 2, the other first term. And so again, these two terms make our first of four terms. Our two outer terms are square root 2 and negative square root 3. And again, the product of those two terms will make our second term. And then our third term, our two inners, are 5 root 3 times 2 root 2. And again, we find the product of these two terms. And finally, our last term, we have 5 root 3 times negative square root 3. So we put our last two factors together. Now, as we combine the factors for each of the terms, the numbers that are outside the radical will stay outside, so I've got a 2 on the outside. But on the inside, I have root 2 times root 2. And I could make this the square root of 4, but this square root of 4 will then simplify to a non-radical of 2. For my second set of factors, I've got negative 1 on the outside, negative 1, and multiplying those two things, I end up with a negative. But when I take the insides of the radicals, I've got root 2 times root 3, and the product of those numbers inside gives us square root of 6. For my third term, I have the outside numbers 5 and 2, so that product becomes 10 on the outside of the radical, but inside the radical I have root 3 times root 2, and that will again give me root 6. And finally, for the product of the last two pieces, I have a positive 5 times a negative 1 on the outside. That gives me a negative 5. And the square root of 3 times 3 is square root of 9. But that becomes a non-radical, and that square root 9 is just equal to 3. So now if I want to put the like terms together, these are integers. I have a negative 15 and a positive 4, so that will give me a negative 11. And then the radical parts here will go together. I have a negative 1, so that's the coefficient in front of the radical, negative 1 square root 6, and a positive 10 square root 6. And that's going to give me positive 9 times the square root of 6. And that's as simplified as we can get it to be. So if we take a look at the last example, using FOIL again, I get square root x times square root x for my two first terms. My two outers are positive root x times a negative root y, so that becomes negative, and I can put these two inside together, square root of x times y. And my two inners, positive root y times positive root x, that becomes positive, and that becomes positive square root of xy. And finally, the last term, positive times negative gives me negative, and then I have root y times root y. And the square root of anything times the square root of itself, that same product, you can think of as being a square, and the square and the square root will undo each other, so we just have an x here. But the two middle terms, this negative root xy and positive root xy, drop out. And our last term, we've got a minus there, root y times root y, will again just give us a y without the square root. So something really interesting happens in this particular FOIL problem, and that is when we have binomials that have the same terms but opposite signs in the middle, that we can get the middle terms to drop out, and we no longer have any radicals in our answer, unlike the previous two problems where the final answer did have radicals. So this very special relationship between binomials, where they have the same first terms and the same last terms with only the difference in the signs in the middle, this relationship between these two binomial factors, they're called conjugates. And we will deal more with conjugates in some of the upcoming problems.